Hi everyone, I'm Zhamak, founder CEO of NextData. A little while ago, back in May, April, I introduced the concept of autonomous data products, a new abstraction that sits on top of the data infrastructure and drastically simplifies the complexity and drastically speeds up the data to first use, the process of getting data to AI and other use cases. Since launch, we've been working with our customers. We've been refining both the concept as well as the implementation. I'm really excited to share what we've learned so far and introduce the concept. And most importantly, why now? Why is it relevant to come up with yet another abstraction and architecture for data management? I will compare the moment we're in to a moment in kind of evolution of the physics. There are times in the history that the very foundational rules and assumptions and the laws of physics that build our systems change. Using a dramatic analogy here, over 200 years, Newtonian physics just worked. We predicted the movement of the planets, we built bridges, we put satellites in orbit, but then it stopped working. It stopped working because we got closer to the speed of light. We got closer to the quantum scale. And then we needed a whole new set of laws of physics, different way of thinking about and building systems. We needed Einstein's theory of relativity to operate GPS and build atomic clocks and particle accelerators. And I think we are in a similar shift in the data infrastructure with the resurrection of AI, with the agentic technologies and big language models, large language models. So let's go into deeper into that. There are three underlying rules of our environment that are shifting, that break the old data architecture: speed, scale, complexity. The system we had built, the existing pipelines and catalogs and marketplaces, that whole system was built for the speed of humans building dashboards, speed of humans building machine learning models. That speed has drastically changed because the application development will be done in sub-seconds by changing a prompt, providing a new intention, and the agent behaving differently and requiring a whole new set of data. So waiting months to get data to applications that evolve in sub-seconds, it's a disconnection. Second, scale. Yes, bad data, wrong dashboards, misled business owners, misled the CEO, and it's terrible, but it's an irrecoverable mistake if we have agents that are making 1,000 decisions and taking actions invisibly behind the scene, ubiquitously across the business. So the scale of impact of bad data or wrong data is dramatically different from scale of humans making bad decisions with wrong dashboards. And last, I want to double click into complexity of the data infrastructure as we introduce these new modes of consumption of data and modes of production of the data. The introducing new models, new storage type, and new applications introduces combinatorial complexity into the system. And this is the point that I think is more relevant to data architecture that I want to double click into. I just came from Big Data London conference and I gave a similar keynote there. And I found it amusing and comical that I saw the same data architectures, the same drawings that I have seen for now many, many years. And now we sprinkled agents and little robots all over them, assuming that by just agentifying the same activities and same architecture, we're going to get a different result and we're going to get a better result. And I'm here to argue with a simple math that that is not the case, that we have to radically simplify the complexity. So let me put the data architecture complexity into a simple formula. And I want to directly talk to the audience here. And if you can think about in your environment, the diversity of every single dimension that goes into the calculation of complexity that ultimately you need to manage. I want people to think about how many of them are storing data in different locations. Many of our customers have data across clouds and still on-prem. The modes of storage, we have to manage the complexity of data being stored in multiple lakes and warehouses and different formats. Many companies process data in many different ways, batch, streaming, and perhaps new ways of processing data. I think there is going to be an emergence of new modes of processing that satisfies agents speculating, 1,000 paths of traversing data before deciding which one they're going to take. Applications, different type of mode of access and consumption to data, and so on and so forth, skills, growth. All of these contributes to the amount of architecture and system complexity that organizations need to manage. So now let's do a quick thought exercise. Let's introduce agents to this formula and see what happens. First and foremost, we end up having a couple of increments on the number of locations. Now we are ingesting data from and accessing data from drives and SharePoints and places that images and files and PDFs were being stored that previously we weren't using in our dashboards and in machine learning models. We are talking about new formats, and some of them are known to them, and many of them will evolve very, very fast. MCP, RAG, vendor embeddings, like these different embeddings for satisfying RAG applications, or MCP for satisfying agentic applications, and many more that we don't even know what they are. This is going to be a very volatile axis of that complexity. Applications, the consumption and interaction of agents, how they discover data, how they use data, it's going to change. The skill of developers, the skill set of developers is going to be drastically different. So just put those increments into the formula, and suddenly we have thousands of new configurations to manage. And where does that complexity sit? That complexity sits in this hurdle of data management that is the squishy bit in between the storage and compute and foundational technology and the applications. And what does it look like today? Looks like this picture, right? It depends on kind of hands-off and manual activities and a stream of building pipelines that cleanse and harmonize and store data, and then downstream layering semantic, and then layering quality after the fact, after the data is actually landed, building complex pipeline around all of that, and then finally try to somehow catalog that in a meaningful way and getting access. So while again, that application layer with that sad agent face is trying to move at the speed of minutes per iteration, that data hairball will move much, much more slowly. So what is the solution? I think, again, if I reflect back to moments in the history of technology that we have faced this level of complexity, and we have gone through an iteration of innovation to manage that complexity, from an architectural perspective, we rely on 3 first principles. And again, I want to invite the audience to think about where in their experience and in the past have seen this level of complexity and how these principles were applied. What we do when we face with this sort of combinatorial complexity, we encapsulate it. We encapsulate it and hide it in manageable units. Then we put simple abstraction and interfaces and APIs around it, and then we automate it and get the human coordinations out of the loop. And again, if we look back to recent history, we have numerous examples of that. We had the example of managing and building applications on multiple environments that led to the complexity of application works on my machine, but doesn't work on the cloud, and it doesn't work on the deployed server, and how can we build applications in a unified way and manage them in a unified way, led to kind of containerization and the orchestration of containers. And prior to that, managing the complexity of writing software on different hardware led to operating systems and standardization of processes and their interactions between the processes. And I think we're in a similar moment. And we have applied these first principles to our software. And what I'm offering is not is something we have built. So it's based on the experience that we have as a company building it and deploying it with our customers. But I hope that others can also take a lesson here and imagine the solution however they want to build it. So what I want to offer here is a new way of thinking about data management, a new architecture, and of course, a new technology to bring that to life. Instead of imagining data management as pipelines and catalogs and marketplaces, imagine them as running applications that are autonomously managing the data processing, autonomously managing the discoverability, autonomously managing their governance and quality, all those different dimensions in an abstraction, in a container. So in this case, what we would end up with, instead of having pipelines and jobs and tools layered over those and a central storage sitting in the middle, we would end up with a set of autonomous, domain-centric, what we call autonomous data products that are consuming and ingesting and processing multimodal data. They process that data, structured or unstructured. They process that data in whatever fashion is relevant to them, each of them, streaming, batch, and they serve that data, or serve access to that data in a variety of modes. They're by default multimodal. They're by default built for a world that is continuously evolving around that layer of data serving and the protocols. And of course, this is only possible if we build those layers of abstraction. In our case, we have built this concept of operating system, concept of drivers, where it allows every one of these data products talk to a different type of storage, talk to a different compute, talk to a different security infrastructure, so that you can keep your existing infrastructure. You can keep your data in your data lakes. You can keep them in the data warehouse. You can run your processing on Spark or wherever that is, but it's all self-orchestrated by these autonomous units. There are no pipelines. There's no cataloging. There's no, the manual activities that need to happen. So let's look at one of these hexagons, one of these containers. Again, this is what I'm sharing here is based on what we have built and deployed. I hope that what I'm sharing with you and offering can create a movement for other people to also imagine what it could look like. So first and foremost, it needs to encapsulate the soup to nuts of that data management and the core pieces that users provide, and it's domain-centric and business-centric. Those core pieces are the semantic of the data, the code that generates that data, the data itself, of course, and the controls that apply it and the rules that govern that data. So that encapsulation at build time and run time brings really all of the different facets that are needed to produce a domain-centric data. The container at runtime needs to be sensing and orchestrating multimodal input, as we discussed before. It could be consuming events, documents, APIs. It's multimodal out of the box. And on the right-hand side, it senses and serves qualified and controlled data in a multimodal fashion. So same data, same semantic, accessed in different modes. And for all of this be possible, we need to have a runtime brain, a microcontroller of sorts, running in the container all the time and doing the sensing and the orchestration and enforcements of the controls. And in our case, it's the Next Data OS kernel a Rust kernel that runs with every single one per data product in the container. And every container, again, to kind of manage the complexity of the infrastructure and diversity of the infrastructure, need to be able to adapt itself to different technology stacks, because it will never, in large organizations, it's hardly possible to harmonize on one stack. So every container decides through this driver technology that it loads at runtime what compute it needs to run the code, what data it needs to store access, give access to the data, what security infrastructure it needs to delegate the access control or audit to, and so on. And most importantly, this is a completely decentralized system with no central orchestration. So for that to happen, every container has a unique URL, globally accessible. I can email it to you, and if you have the right access, the container will give you access to the underlying data. And through that URL, discoverability is automatic. Observability is automatic. Control and pushing policies down to the global policies to get compliance across a fleet of these data products is automatic and API centric. So what does it look like when you deploy it? This is a simple example of a data product sitting at the center of this diagram and automatically providing customer feedback across different channels of the business to an agent that answering questions such as what is the for example the data products that are causing most complaint. So let's go through what does that experience look like in terms of the architecture and in terms of the application of the agent. From the architecture perspective, every one of these data products, you have 3 of them or 4 of them actually on this diagram, are autonomous, independently running. They own their own dependencies. So we have two upstream data products, one serving PDF and metadata around customer feedback that has been captured, through maybe notes or files or, at the point of sales, and the digital reviews of the products on Amazon. And all of that gets aggregated by the downstream data product, customer feedback data product. And before any of that data makes it to the customer feedback data product processing, that data product imposes all of the integrity and quality checks. And once aggregation is done, the overall aggregate of customer feedback cross channels would get checked again. And before that data gets promoted, once it passes the integrity rules and quality rules and compliance rules, then the data becomes available in multiple modes, as embeddings, as SQL tables, as documents, as MCP endpoints. So one thing to maybe have a different session to go deep into is the articulation of semantic to go beyond formats and structure and include the questions that the data can answer in a protocol agnostic way. That is why it's possible to have a single semantic cross-channel customer feedback and many modalities that require data modeling and API modeling as one unit. And that's an interesting topic. So then what does the agent lifecycle look like? It starts with an intention that's given through a prompt, whether that prompt is hard-coded in the code of that agent or it's an interactive session with a real user. And based on that intent, the agent needs to evaluate what tools, what resources it needs to use. But for that to be possible, a domain semantic first way of sharing what resources are available needs to be presented as part of the context to the agent. So the question around what tools do I have available to me are actually answered by a data product itself. I mean, the beauty of this system is that everything is a data product. You don't need a separate catalog or a separate place to store information. The metadata about what tools from these individual data products that have been meshed together are available is answered by a system level metadata kind of data product. And that enables the automated discovery of relevant source of data. And this is very different from, wiring an endpoint to a warehouse or a lakehouse, because here you are wiring very domain-centric information, so you get access to the right information and not kind of overloading the context window for the agent to hallucinate with irrelevant information. So ground up, it's domain first, as opposed to semantic layered slapped on top later on. So once it discovers the right tool, it goes to the data product, and from the same data product, it can get the data in the relevant mode. In this case, would be through an MCP tools. Perhaps it can answer that particular question, and then the access control, of course, gets imposed right then and there at the data product itself, and the relevant answer is provided. If this wasn't in place, if this multimodal, autonomous, and independent unit wasn't in place, then what we would be doing? We will be building pipelines for each of these modalities, a different pipeline. We're putting them in the same storage or different storage. We will be, wiring and linking kind of discovery and lineage and all of that on top of it. And maybe we get it right and maybe we don't get it right. None of that is necessary, because fundamentally this autonomous abstraction, its job is abstracting orchestration of multimodal input, multimodal output, with governance as computational code built into it. So what I want to, I guess, pose here as something to think about is that for quite a while, we have been fascinated and built an ecosystem, an architecture, and technology around storage. The bigger, the better. And then we accessorize the storage. We accessorize it with pipelines that go in it. We accessorize it with catalogs that get data out of it. We accessorize it with quality tools that look at the data on the disk. That is the modern data stack. That is the evolution of the architecture we're dealing with right now. And that architecture was built for humans building dashboards, for humans building machine learning models. What I want to offer here, a different way of thinking about architecture, data management, thinking about it as autonomous data that produces, that is responsible for producing itself, for governing itself, and imagine it as a mesh of interconnected autonomous units. Yes, there will be a larger storage underneath all of this, storing the data, but that's the secondary concern, because for some use case, maybe that autonomous data needs to be accessed through a warehouse storage. And for some other use cases, it may need to be accessed through APIs. And all of that should be possible through a domain first. And I want to kind of offer this as the next generation of data architecture, what comes after data 2.0, data 3.0, with this autonomous abstraction at the core of it. So let's iterate through a few capabilities. I think I already covered a few of those characteristics. Well, what is the characteristic that we are shifting from, and what is the impact of that? Why do we need any of these shifts? So I think the one that is really key here to think about is this decentralized and domain-oriented semantic-first nature of the data, this unit of data management. Why does that matter? Because unlike machine learning models, that we had more data, we could write regression algorithms or models that weren't overfit to a curve. In this particular case, in the case of large language models and agents, the more data we provide, the more opportunity for hallucination and irrelevance we create. By default, the serving of the data, the creation of the data, not just the serving of the data, the creation of the data needs to enable this context-aware ground truth for the agents to do their job. So moving away from a storage-oriented, schema-first, centralized model of data management to domain-first and semantic-first, I think is the most differentiation angle to this. And again, I don't mean slapping semantic on top. I mean, generally producing the data across domains. And I think that was a foundation that data mesh also introduced to be able to scale data management. Second, multimodality and the continuous shift of the modalities as well. Agents use many different protocols, and some we know today, and some will evolve very, very rapidly. Last year, the hot topic was RAG. This year, or graph RAG, or different types of RAG. This year is MCP evolving fast, and who knows what's going to be next year. So whatever technology we bet on today, it better be multimodal out of the box. It supports multiple formats of ingestion and serving and multiple protocols of serving data. So single format, single usage, it's going to create a lot of complexity into the architecture and into the system. The next point is about discoverability. It's very clear that agents are not going to log into a UI and search for and explore data. They are going to automatically find the right data based on the intent and based on the questions. So that intent-based automatic discoverability requires a very different modeling of that discoverability approach. So again, semantic first, of course, helps, but API first, everything accessible automatically through APIs as opposed to manual discovery and access. Orchestration shifts. Manually integrated pipelines will shift into automatically self-orchestrating autonomous units that they can sense what the dependencies are and when they change, because pipelines and manual orchestration and this mode of orchestration has a big bottleneck and turns into kind of hairy architecture that's really hard to manage. And bottom line is time, long time to get data to first use, and lineage. If we and the next one is about reasoning. So today, a person reasons about the source and origin and the intent of the data by following a lineage of that data. And in many cases, that lineage is slapped on after the fact, again, onto the data processing pipeline. And sometimes it's in place, sometimes it isn't in place because it's introduced after the fact. For models to be able to natively built in data reasoning, which we absolutely need to trust these autonomous systems, built-in lineage is across different stacks is necessary. Again, a lot of lineage technologies tie themselves to a particular storage, particular compute, particular stack, particular cloud. So across cloud, across stack, built-in lineage. Finally, the last point, the instant safety built into agentic usage would require a drastic change around governance. Governance today is after the fact. You produce the data and then you check its compliance. It needs to shift left to be self-orchestrated and imposed in the flow of the data inside these autonomous data products as computation, as code, before data gets in or gets out. So, bottom line, for many of you that have been following me and are familiar with my work, you know that I've been I've been working on fixing this data productivity curve. What you see here, what I call a data productivity curve, what it shows that the more ambitious companies become, and their ambitious is displayed on that x-axis, that data ambitions of a company is represented by their complexity, meaning the number of use cases they want to use data for, the new modalities with agents and others that they want to use the data for, a number of business units that they want to be enabled using data. The more ambitions they become, the slower their speed of innovation with data becomes. So then we need to change this plateau. And I put some numbers here that maybe for many of you might be familiar. Right now, based on first-hand experience, again, over the last 7 years working with hundreds of enterprises, it takes about 6 months to go from a complete new source of data, whether that's in some SaaS application or purchase data, to first use by business to have an impact on the business, takes about 6 months. And 70% of effort of people working on data to value stream is spent on keeping the lights on. And based on recent MIT report, companies attempting to use AI get stuck with 1 or 2, 3 use cases. So clearly it hasn't worked and it isn't working. And AI is exposing how unfit this data 2.0 pipelines and catalogs are. So we need to bend this curve. And to bend this curve, we need to think about a different approach that gives us 50x faster data to value and with radical simplification of the data stack. And that's what I call data 3.0. We want to show you live in action with actual software in the next call. So take a screenshot of the QR code I have here to get your hands on a sandbox, and we will be showcasing the new capabilities of the autonomous data products very soon. We continue to publish resources for you on our website, so check us out, check out the new webinars that we had, and I hope we can keep the conversation going.